Good evening, 7th grade math and aka FOM. All right, so let us review what we learned in class today. The big topic was, let me just scroll this down, pull this down a little bit. The big topic was number sets. Okay, number sets. We learned that in a real number set, inside a real number set, right here, let me draw a big box right here. This is a whole real number set, okay? Now, inside a real number set, there are two subsets. Subsets are like baby sets, right? Real number set is a mother set, and there are two babies inside, and the baby sets are irrational. Ooh, that's too thick. So irrational set and the rational number set. Okay. Now symbol for rational is Q. Symbol for irrational set was Q prime. And we have three circles. 1, 2, 3. There are three more subsets inside a rational set number set, and the innermost circle, that was natural number set. And the examples were 1, 2, 3, and etc. It goes on forever, and we said how there are infinite number of elements inside a natural number set. And then the outer circle was a whole number set. And the elements were all the natural number set elements plus 0. That's the only difference between the whole number set and the natural number set. Now the outer circle, bigger set, was integers. Okay, the set had all the whole numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 10. It goes on and on forever. And then the opposite side of the number line, which is negative whole numbers. So it's really plus or minus negative whole. I can just use a symbol W, right? That means 0, 1, 2, 3, and it goes on. And also the other side, negative 1, negative 2, and then negative 3, and the list goes on. That's right. Rational numbers were the numbers that are rational yet are not elements of integers. There were any number that can be written in fraction form, A over B, where A and B are both integers. Okay, and we can totally use this statement. The symbol we used, A, B, are elements of integer, and B does not equal to 0 because the denominator of a fraction should not equal to 0, otherwise it will be undefined. Okay, so irrational number, classic example, definitely is a pi radical 5. We cannot come up with a number that multiplies by itself twice to equal 5. It'll be ugly decimal, which means it cannot be expressed as a fraction. What else? Any non-repeating, non-terminating decimals. So repeating decimals are all rational numbers. So 0.3 repeating, we said in class, is actually 1 over 3. That is a fraction, right? So 1.3 repeating is a rational number. And that confirms that all repeating decimals are rational numbers because all repeating decimals can be written in fraction form. What else? Just because, let me make up a pattern. 1, 2, 1, 2, 3, 1, 2, 3, 4. You see there's a pattern, right? Just because there's a pattern, that doesn't mean the number is a rational number. Simply because it just cannot be written in a fraction form. So that's clear, right, guys? Next, then we learned symbols, set symbols, such as, check this out. Here's a problem I had already prepared for you guys, very similar to what you guys have to do for tonight. So there are 4 sets, set A, set B, set C, set D. Notice how I introduced in class braces. they are used to group sets, okay? So set A has 4 elements, -4, -2, 1, and 3. So you can say simply -4 is an element of A. I'm just grabbing random numbers, okay? 7 is an element of set A, and the -1 is not an element of set C. What else? 2, 4, 6, 8. So I see a pattern. This is a set of even numbers, right? Except for 0. So let's say 11, which is an odd number, is not an element straight down set D. So that's what we learned in class today. All right, you guys want to try number 30 with me? Again, these numbers are the problems are really similar to what I signed for homework, okay? Which set is an infinite set? Do you remember what infinite set meant? Infinite set means a set with lots and lots of elements inside. As a matter of fact, too many that we call it. Now it's not countable. It's non-ending, infinite, okay? It's not finite, it's infinite. So which set is it? That's right, it is set, whoa, what was that? Sorry. All right, set D. Number 31, meaning there's endless number of elements inside, right? All right, so 31. Which of our defined number sets include set A, B, C, and D? Our defined number sets are, you guys were confused by that phrase, right? Defined number sets were all these the set names we mentioned here. What were they? Rational number set, irrational, integers, whole, natural. Those are defined number sets. So, knowing what they are, let's go back to the problem. Which of our defined number sets include sets A, B, C, and D? Take a look at these numbers, okay? Set A, -4, -2. It's a combination of the elements are a combination of, these are just integers, aren't they? I don't see any fractions particularly. Same with set B, C, they're all integers. And then D, it's got like a whole bunch of even numbers, which are all natural numbers. So if you say defined number includes all of them together, right? Then it will be, I'm going to list them from least to greatest, okay? So these are elements from all the 4 sets. All right, so -6, -4. -4, I believe, is repeating, but it doesn't matter. -2, and then grabbing 0. I also see 1. I also see 2, and I also see 3, and 3 is repeating. That's okay. So 3, and do you guys see anything? 4 is right there. 4 is right there. And then I see 5, and then I see 6. Is 6 repeating? I don't think so. And is 7 there? Yeah, I see 7 as well. And what else do you guys see? I also see 8, and then that's about it, right? So union, meaning combination of all 4 sets is really this. Okay, really that. What would you name that? Which of our defined number sets include? What set includes this? Wouldn't that be integer? Because it's negative whole numbers and some of the positive whole numbers with 0. Okay? All right, next. And that is 32. Again, these problems are very similar to the homework problems you have to do for tonight, but they're not the exact same numbers. Which of the named sets is a subset of the set of natural numbers? So let me erase just to help you understand better. Okay, let me just get all these messiness out of your way. All right, so which of the named set, which one, A, B, C, or D, is a subset of the set of natural numbers? Subset of, baby set of the set of natural numbers. Which is really asking you which of these sets, A, B, C, or D, is a baby set, is part of the natural number set. What do y'all think? Isn't this set D? Why? It's because set A, B, and C, they have some negative, numbers inside, right? Which are not natural numbers, okay? 0 is also not a natural number, so D is the only pick we have. All right, number 4. We're almost there. Create. Ooh, I wrote the answer in the incorrect space. All right, number 33. Create a Venn diagram. So we learned about Venn diagram today. Right? That's like a big thing we learned today for the first time. Venn diagram illustrating sets A and B. Remember how we drew the Venn diagram? So Venn diagram usually can be in a large pool like that, rectangular pool. Venn diagrams are consisted of circles, usually at least 2 circles. So we're comparing set A and set B, right? So 1 and 2 circle. I'm just about to draw 2 circles. Do you think we're gonna have 2 separate circles like that with no overlap, or these circles will overlap? See, okay, let's just see. So I'm gonna name this set A and the other circle set B. And I'm going to list the elements of set A, which are -4, -2, comma. Always use commas when you list numbers 1, 3. And then elements of set B are -6, 3, and then 5, and then 7. Do you see any elements that overlap? I do. What is it? Have you caught it? Isn't it 3? So what I'm going to do is that I am going to put that overlap, the intersection, right, where they intersect at the element 3 right there in the middle. And then what works really neatly is that I'm just gonna get this out of the way. So 3 is no longer in each set diagram, the circle. So it exists right in the middle. That's the intersection. This is the intersection of the 2 sets A and B. Okay? Yeah, that's it. This is the Venn diagram illustrating sets A and B. You guys want to try the last one? Well, if not the last one, let's try one more, okay? Create a Venn diagram illustrating A and C. All right, so this time we're doing A and C. Okay, one more rectangle. A and C. I already see, you guys, check this out. I already see some intersection, -4, -2, and that's about it, right, guys? So let's draw 2 circles with intersection A and B, -4, -2, 1, 3, -4, -2, 0, and 2. You know what? Where is the intersection? Where do they overlap? Here we go, -4 and -2. Don't we write that in the intersection part? -4, -2. And then we have to make sure that it doesn't show in each circle, in each group, each set. So I am erasing those 2 elements in each one. That's it. That is it, you guys. Okay? All right. Good job. Okay. I will see you tomorrow. Have a good night.